Hello, this is Mr. Huber. In this lesson, we're going to look at the graphs of quadratic functions and transformations of that graph. So we can start with the graph of y equals x squared. This is our basic quadratic graph. First thing to point out, when we see a squared as our exponent, the highest exponent in our equation, that is in a quadratic equation or function. And when we graph something like this, it's going to have the general shape of a parabola. A U shape could be either opening up or opening down. Okay, we're going to see, we'll graph this one exactly, then see some other examples, but when you see a quadratic function, you should understand its graph is essentially going to look like one of those U's. If we want to graph this function, if we want to graph anything, we can always make a table of values to see what numbers we might have for x and y coordinates. In this case, we're going to plug in -2, -1, 0, 1, and 2 as x values. If we put a -2 into the equation, so we're going to plug it in right here, -2, and we square it, -2 squared is going to be a positive 4. -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So we could see, if we went to draw the graph for this particular function, we could have x values. We're going out to -1 and -2, and then 1 and 2 on the positive side. And our y values would go up to 4. And so if we graph these points, we'd have -2 comma 4, -1 comma 1, 0, 0, 1 comma 1, and 2 comma 4. And we could see that we would have a graph that is a U shape like this. And it would go down through that origin there. We want to make sure we hit through that. And we put arrows on either end because the graph could keep going in both directions. So we can find anytime what a graph will look like by plugging in some values. When we graph quadratic functions, which values we plug in for x is going to depend a little bit on what the equation looks like, which we'll get into. But again, keep in mind this graph is called a parabola. Okay? Anytime we graph a quadratic function, we're going to get a parabola-shaped graph. If you don't, that would be a sign that maybe something's off with what your graph should look like. Okay? So let's look a little bit at what the equation could look like and what the particular elements of a quadratic function are. In vertex form, and that's the form we're going to look at here, equations in vertex form looks like this. Okay? Right up here we had just an x squared. Well, we could have other things going on with that x squared side of the equation. Okay? We can have an h and a k value, which are the coordinates for the vertex. This point right here, the bottom of the U or the top of the U, if it was one that was opening down, that is called the vertex of the graph. Similar, we saw absolute values, and their graphs had a vertex. Okay? The axis of symmetry is a line that goes vertically straight up and down through the middle of the graph, through the vertex. And we'll talk about that portion of the graph. And if this a value here is a positive number, your graph's going to open up, like we see here. If this a value is a negative number, the graph's going to open down. Okay, so pay attention to what the a value means and how that affects the graph. So we can get from this equation the vertex, the actual point of the vertex, h comma k. We can know if it's going to open up or down, and then from there we can get some more exact points to graph. So let's see what that might look like. We're going to graph this equation. We're going to label the vertex and axis of symmetry. Those are kind of key pieces to this graph. So one of the things we're going to do when we make our table of values, again, is understand which values we should plug into our table for our x's. Let's first talk about the vertex is going to be minus h, so minus a -2, like we saw with our absolute value functions and graphs. Our x value of the vertex is going to be -2, and the y value is going to be -3. So the vertex of this graph, right, the vertex right here, is going to be -2, comma, -3. The vertex is going to be -2, comma, -3. That -2 is going to be the middle value in our table of values. And then we want to have two numbers on this side of x and two numbers on this side of x. In terms of if we're at -2 for the vertex, we want to have -3 and -4 and plug those in, and then on the other side, -1 and 0. So when we have our table of values written out, it's going to be -4, -3, the -2 there, -1, and 0. Those need to be the numbers that we use for our x values to plug in and get y values that go with them. And when we plug a -2 in, we should get -3. That's the whole point of why that's the vertex, and we do. If we put a -2 in here, -2 plus 2 is 0, squared is still 0 minus 3. That gives us -3. Let's try -1 now. If I plug a -1 in here for x, plus 2, that's 1. 1 squared is 1. 1 minus 3 would be -2. So I have -2 for my y value that goes with an x value of -1. And if I plug in a 0, I'm going to have 2 squared is 4. Minus 3 is a +1. And if you plug -3, so if we take -3 out here and we plug it in, plus 2 is -1. -1 squared is 1. Minus 3 is -2. And if we plug -4 in, we'll get a y value of 1. You should see where our vertex is, -2, -3. When you plug in those x values on either side of the vertex, your y value should match up. -2 and -2, 1 and 1. That's another good sign that you're getting numbers and calculations that are coming out accurately. So let's graph this then. We're going to have -2, -3. That's our vertex. Okay. Then we're going to graph -1, -2, and 0, 1. And then the other side of -2, we had -3, -2, and -4, 1. And so we can have a parabola that looks like this. Okay? Our vertex is at -2, -3, as we saw already. The axis of symmetry. The axis of symmetry is going to be a vertical line that goes through the vertex. So it's going to be, I'll put it in a greenish color here, this vertical line that goes straight down through the vertex. It's going to have an equation of x equals -2. The axis of symmetry is always going to be the x value of the vertex because the axis of symmetry goes through the middle of the graph. The vertex is that point that's either at the bottom of the parabola or the top of the parabola, depending if it's opening up or down. So the axis of symmetry always goes through the vertex and will always have the same x value, in this case x equals -2 of the vertex. Let's see another example here. We have the equation -2 parentheses x minus 1 squared plus 5. So the first thing to do would be find the vertex. Okay, so let's identify the vertex is going to be at 1, 5. Okay, and then we can make a table of values where that 1 is going to be our middle x value. And then we have two numbers on either side of it. And if we plug a 1 into the equation, we're going to get a 5. Okay? Let's plug 0 in. And if I plug in a 0 here, 0 minus 1 is -1. I square that, I get 1. 1 times -2 is -2, plus 5 gives me a y value of 3. So I get a y value of 3 when I plug a 0 in. And if I plug in a -1, of -1 minus 1 here, -1 minus 1 is -2, squared is 4. 4 times -2 is -8, plus 5 would be -3. So I get -3. And if you plug in a 2, you'll also get a y value of 3. And if you plug in 3, you'll get a y value of -3. You can try those, make sure those calculations are coming out, and you should see that we're going to have values here for these vertex. On either side of the vertex, our values are the same. So we can graph these points now. So we'd have 1, 5 as the vertex. Let's make that a little darker. 1, 5 as the vertex. There you go. And then we'd have 0, 3 and -1, -3. And then on the other side of the vertex, 2, 3 and 3, -3. and we're going to have a parabola going through those points and looking like this. Again, arrows on either end because it will continue past those points we have there. So our vertex is 1, 5. Our graph looks like that parabola opening down because we had an a value that was negative, so it's always going to open down. We have an a value that's negative. And then we're going to have an axis of symmetry right down here through the middle of the graph of x equals 1. Again, the same x value as the vertex. All right. A diamond diversion. Who was the MVP of the 1984 World Series? The MVP of the 1984 World Series was Detroit Tiger. They won the World Series that year. Alan Trammell. Alan Trammell was the World Series MVP, and he was recently inducted into the Baseball Hall of Fame in 2018. He had his number 3 retired by the Tigers in 2018 as well. Alan Trammell was a 6-time All-Star. He won 4 Gold Gloves, and he, along with Lou Whitaker, who was a second baseman, Alan Trammell played shortstop, they combined for the most double plays by a single shortstop second baseman combination in the history of professional baseball. And they also have the American League record for games played together as teammates. So Alan Trammell, a long-serving member of the Detroit Tigers, and a pretty accomplished one at that. If we look at here a couple more equations, and without graphing, just looking at identifying the vertex, axis of symmetry, maximum, minimum values, domain and range, some key things, we can plot points and get those to plot on our graph and draw the parabola. We want to make sure we kind of understand what's going on, and we see this equation. There's some valuable information without even graphing it that we should be able to identify. So let's first talk about the vertex. Okay, the vertex for this first graph is going to be at -2, -8. The axis of symmetry is going to be x equals -2. Those are similar things we talked about from those last couple graphs. Now let's talk about a minimum or maximum value. What do we think this graph is going to look like? Well, with this a value being positive, it's a +3, that means that the graph is going to open up. It's going to be a graph like this. Without plotting exact points, the vertex would be somewhere here, and that vertex is going to be a minimum value. You can see that's the lowest the graph is going to get. So it's going to have a minimum value. Anytime a parabola opens up, it's going to have a minimum value. That means a lowest possible value. That lowest possible value would be the y value of the vertex. So the minimum value for this is going to be y equals -8. Okay. And then the domain and range. Domain is x values. So the domain for this particular graph could be anything. You could put any number you want in here for x. There's no limit to what you could plug in for x. You could plug anything you want in there. So the domain is all real numbers. Okay? You could have any number you want in there as an x value. The range is y values. Well, we can't have any y value we want. Or we can see right here, the y values are going to get to a minimum point and never go below that. So the range is all y values that are greater than or equal to -8. Okay? Right? Domain is inputs, in this case the x values. It could be anything. You could plug any number you want in for x. But the range is not going to be any possible value because you're never going to get a y value less than -8. So the range is y values that are greater than or equal to -8. Again, this h and k value give us the vertex. The axis of symmetry is always going to be x equals whatever the x value of the vertex is, because that's going to be that line that goes straight up and down through the vertex. The minimum value for this graph, because it is a minimum, because if we see the graph here, it has a low point. The vertex is a low point because it opens up. So the minimum value is going to be y equals -8. Let's look at this next equation and talk about those same pieces of information for it. Okay? If we look at this here, we've got a vertex of 1, 5, from that h and k value. We've got an axis of symmetry of x equals 1. In this case, we're going to get a graph that opens down. It opens down because we have a negative number here for our a value. Negative a value means it's going to be opening down. Okay, that means we're going to have the vertex right here. Right, that's the vertex. Is that point? Okay. And that means it's going to be a maximum value. Okay, a maximum value of y equals 5. If we graphed it, there would never be a y value greater than 5. The domain is still all real numbers. We can have any number we want as an x value. The range is y is less than or equal to 5, because the y value is going to be maximum value of 5. That means y could be 5 or anything less than 5. It could be 5 or anything less than 5. Okay, so keep in mind, h comma k for the vertex, h comma k for the vertex. Axis of symmetry, whatever the x value is. Axis of symmetry, the x value, that line that's going to run straight up and down through the middle of the graph. This x equals 1 would be straight up and down through the middle of the graph. I'm going to have a minimum value for any parabola opening up. I'm going to have a maximum value for any parabola opening down. My domain will always be all real numbers because I could plug anything I want in for x, and the range is going to be based on, are the y values greater than, going up from some vertex, or are they going to be less than because we have y values below, going down from that vertex. And these are pieces of information we can get. We did not draw exact graph. I drew a little sketch to see does it open up or down, but we didn't get a table of values, graphed exact points, and we can still tell all of that valuable information just from looking at the equation. We got to get comfortable with that, and then the graphing can come.